Awesome. Okay, well, look, everybody, I hope this will work. I'm used to using Zoom a lot for my classes at LSU. This is the first time I think I've used GoToMeeting where I'm actually the presenter. But we'll give it a try. We'll do our best, and we'll see how it goes. As you see, for those of you who may know me, during lock-in, I've grown a beard. I haven't gotten a haircut. I'm kind of a mess, but I wasn't expecting actually to be on video during this presentation. So we're going to do our best and hopefully give you guys some really good information. We're going to have 3 presentations today. And obviously what this session is about evacuation. But what we're going to do is we're going to not just talk about what has happened in past evacuations, which we will do, and some of the research that we're doing, but also looking forward, looking ahead. So the presenters who are on this and I, along with some colleagues, have just completed a study actually traveled during the COVID-19 lockdown process. So what's very interesting is effectively what we have done is we have kind of turned around the data that we would normally use to assess and evaluate evacuations in the state of Florida. And we use those same data sets to actually look at who's not traveling or who wasn't traveling over the past several months. So with that, we're going to have 3 presenters. We're going to have kind of a team presentation on some research that was done at Clemson University by Dr. Pamela Murray-Tuite and her grad student, Emmanuel Adjei. And she's going to talk about using this sensor data that I just talked about to estimate basically the people who are not, who didn't stay during Hurricane Dorian. And then the second presentation is going to be by Scott Parr, who is a professor at Embry-Riddle University there in Florida. He's going to be talking about the use of sensor data to analyze hurricanes Irma in 2017 and Michael in 2018. And then I'm going to come back at the end and talk a little bit about the study that we did that shows what the traffic and travel patterns were during the COVID lockdown period and how that might actually influence what we may see if there's going to be evacuations in 2020. So what we're going to do is each go about 20 minutes or so, and then that should leave maybe 15 or 20 minutes or so after that for questions. So we're going to hold off on questions until the end. We'll try to get through each of these presentations as quickly and completely as we can. Then we'll turn it out over to the audience for questions. So with that, Pam, Emmanuel, what we're going to do is put it over to you, and if I can do this right, we'll see. So Emmanuel, you are now a key presenter. I'm not sure exactly what it looks like.
Thank you, Brian. So I'm just going to give an overview of the motivation for our study. So one of the things that we had noticed during Hurricane Dorian was that there were estimates of the number of evacuees. But what we didn't know exactly was with all of the tourists that we see on the islands of South Carolina during Labor Day weekend, was how many households would remain on the island given the evacuating vehicles that they had provided. So we went through trying to figure out and reason through what assumptions we would have to make in order to be able to estimate how many people would stay behind. And so that led us to this particular study. And for the details and the results of that, I'm going to turn it to Emmanuel now. Thank you.
Yeah, thanks, Dr. Pam. So just like Dr. Pam rightly said, we've conducted this study, and it's on using sensor data to estimate quantities of stayers for Hurricane Dorian. And it's basically about 3 areas in South Carolina. So just as today is June 1, we've officially begun the hurricane season, and at some point within this season, some coastal residents may be asked to leave their communities or their areas due to an impending hurricane. And the main goal of hurricane is to minimize damage to properties, um, avoid injuries, and to prevent loss of lives. And that most evacuation modeling have taken care of those who have left their communities. With quite recently, Alawade et al. Modeling for those who might have taken part in partial evacuation. So the question is, how do we account for those that would remain behind? This study presents the estimation of remaining household for Hilton Head, Buffalo, and Myrtle Beach areas in South Carolina during Hurricane Dorian in 2019. Estimation of remaining households would help public agencies to determine the number of food and water supplies that could be sent to households who may need to be transported to public shelters should the situation get worse, and also for them to be able to determine alternative means of transportation, such as boats that could be used to evacuate residents should the road network fail, as some coastal areas are island. So this is a brief timeline about Hurricane Dorian. It's basically hit the Virgin Islands as a category 1 hurricane in August 28, 2019. And 2 days later on, the National Hurricane Center upgraded it to a Category 4 hurricane with a maximum winds near 130 miles per hour as it approached Florida. On that same day, the governor for South Carolina issued an mandatory evacuation order for the residents of South Carolina to leave, but this order became effective on September 2nd. On September 5, these orders were lifted for Hilton Head and Buffalo residents, and on September 6, this order was lifted for Myrtle Beach residents. Specifically for this study, we gathered data from the South Carolina, we gathered hourly sensor data from the South Carolina Department of Transportation website from September 1, 2019 to September 14, 2019. We also gathered household data and number of vehicles per household data from the US Census Bureau, and we also gathered tourist data from published tourist reports. So with the traffic data, traffic counters automatically count the number of vehicles that pass on it and record the amount of traffic for a given time period. This could be every 15 minutes or every hour or even for the entire 24 hours. The data collected showed the number of vehicles traveling in each direction, and this direction is either in the northbound, southbound direction or eastbound and the westbound direction. And that we determine the number of inbound and outbound vehicles from the study areas based on the direction of travel. So just as it is shown on the right-hand side, we have the traffic counter and we have the direction of travel. So these are those that are leaving the study area, and these are those that are entering. So we call those leaving the outbound, and we call those that are coming in inbound. So this is a map showing the various study areas that we considered. We considered Hilton Head, Buffalo, and Myrtle Beach, and the the blue circles indicate the sensor locations for the respective study areas. So we then decided to plot the difference in the vehicle count and to see the pattern of this data. So A corresponds to when the mandatory evacuation order was in effect. B corresponds to when Hilton Head and Buffalo areas were asked to, when the orders were lifted, and C is when actually re-entry began for these residents. With regards to the hour axis, they have been segmented in 24 hours for easy reference. And just like you see down here, 75 and 15 hours, 15 are in hours. And this is for Hilton Head, and the right-hand side is for Buffalo. This is specifically for Myrtle Beach, and what is a bit different with Myrtle Beach is that because the order was lifted later on after Hilton Head and before were lifted, the difference in hours between when the order was in effect or was effective and when the orders were lifted is 94 hours as opposed to 75 for Hilton Head and before, and for 15 and for 20 hours as opposed to 15 for Hilton Head and before, between when the orders were lifted and when re-entry began. So the method used, both hourly sensor data and the number of vehicles data we gathered were then used to carry out sensitivity analysis for us to be able to determine how many households were staying behind for each hour. And we based our analysis on 4 parameters and assumptions. And the first parameter is the average number of vehicles per household. Our range varies from 1.0 to 2.21. But the highest range or the largest range that has been reported in literature is from 1.0 to 2.15 by Lindell et al. In 2011. The second parameter is the percentage of households who carpooled, and this is between 7% and 13%. The third parameter is what households who use public transit, and these percentages range from 1% to 16%, and percentage of tourist vehicles, and this ranges from 90% to 100%. So this basically shows us how we estimated the remaining households based on the average number of vehicles per household. And for the remaining household for this particular hour is equal to the remaining households for the previous hour minus the difference in vehicle count over the divided by the average number of vehicles. So this graph specifically shows the remaining households for Hilton Head, and the red line represents the average number of vehicles per household for all the residents in Hilton Head, which is 2.05. And the assumptions here is that we assume that there was no tourist vehicles in the traffic stream, none of the households carpooled, none of the households used public transit, and there was no inbound official vehicles. And what we could see here is that the lowest point occurs around the 120th hour, and the difference between the least point for average number of vehicles 1.0 and that of 2.15 is 12,730. A similar thing is seen here. However, the average number of vehicles per household for Buffalo is 2.21 as opposed to 2.05 for Hilton Head. And for Buffalo, the range of values for the least point for these this range is 9,757. Then we come to Myrtle Beach. Myrtle Beach has average number of vehicles per household in red for the entire resident to be 2.07, and the range of values for the least point between 1.0 and 2.15 is 26,667. Then we get to percentage of households who carpooled, and basically what is different here is the percentage of the carpooling household multiplied by the difference in vehicle count divided by the average number of vehicles per household. And all our assumptions for the carpooling households, the households who use tourist vehicles, and those that used transit are all based on, we are using the base case of average number of vehicles 1.0. So these graphs are a bit similar to the average number of vehicles per household in that we still have our A, B, and C showing. And just like I said, the average number of vehicle per household of 1.0 was used as the base case. For the difference in the range value, we have 1,000 1,425 for percentages ranging from 7% to 13% for Hilton Head, while we have 1,060 between 7% and 13% for Buffalo. And for the assumptions, we assume that there is no tourist vehicles, none of the households use public transit, there was no official inbound official vehicles, and our last assumption is that the carpooling households is equal to the number of additional vehicles taken by other households who might have been in the traffic stream. Then for the last graph with regards to carpooling households, we have that for Myrtle Beach, and we have the difference for the range, the difference between the range of values that we assume to be 2,972. Then we get to percentage of households who use transit, and this equation is similar to that I showed for those that use carpool, just that percentage of carpooling has been substituted for percentage of transit. So here we have similar thing, just like I showed for the carpooling households, and the assumptions here include that there are no tourist vehicles, none of the households who carpooled, and there is no inbound official vehicles. And for the range of values that we assume, we have 1% and 16%, and the difference between this range for the least values for Hilton Head is 3,576, while that of Buffalo is 2,671. That of Myrtle Beach is 7,470. And finally, we get to percentage of tourist vehicles. And this equation is a bit long, but for those in the parentheses or brackets, we have the vehicle count and the average number of vehicles. This part of the equation is similar to what we've seen before. This part is also similar. The only thing that is different here is the percentage of the tourist vehicles and the total tourist group and the total number of households for each study area. So how did we come up with the number of tourists that we use for our analysis? Let's take Hilton Head, for example. The total number of visitors in 2019 is 2,670,000. And we assume that one tourist group was equal to 2 visitors, where each tourist group is equal to a household. And so they are likely to evacuate as a unit. And we have 1,335,000 tourist group for 2019. Using visitors factor of 16.2% for August, we have 216,270 groups for August. And dividing 216,270 by 31 days, we have this value for each day in August. And multiplying this for a 3-day Labor Day weekend, that is Saturday, Sunday, and a Monday, we have 20,930 tourist groups. So this is the total number of tourist groups that we use for Hilton Head, and that is how the others are computed. So the assumptions here include none of the households use transit, none of the households carpooled, and there was no inbound official vehicles. And that the last assumption is that remaining tourists after 8/31 are approximately equal to the number of residents who are out of town. And as usual, the base case assumed here is that average number of vehicle of 1.0 was used. And here we see the difference in the range to be for the least point occurring at the 120th hour to be 1,261 for Hilton Head, with a total tourist group of 20,930, as opposed to 413 for Buffalo, with a total tourist group of 15,678. That of Myrtle Beach is a bit huge, comparing that to their total number of households. And this graph is a bit different in terms of the assumptions that we came up with, because their total tourist groups were somewhere close to the total number of households. So with our last assumptions, we modified this a bit that 1/10 of the remaining tourists after 8/31 were approximately equal to the number of resident households who were out of town. And the range of value for between the difference for the range of values assumed is 3,636 for Myrtle Beach. And so this table represents a descriptive statistics of the analysis that we've conducted, and it basically is supposed to give the range of values, the least points that we have talked about. So 1.0 here corresponds to 15,537, while 2.15 here corresponds to 28,277. And this column represents the midpoint between these two values, and this is the percentage difference between these two values. And we then came up with a critical parameter that public agencies and researchers would want to focus on, which is the tourist vehicles in the traffic stream. So a similar thing is shown here, but interestingly, the range of values for tourists are higher as compared to the other parameters, and they also have higher midpoints as compared to the others, pretty much indicating that most of the households remained per the percentage of tourist vehicles. So in conclusion, the results indicate that for the number of evacuating tourist vehicles parameter, most of the households remained as compared to the other parameters. And this is because most of our study areas are beach areas and popular tourist destinations that attract most tourists. And this is evident in the table shown here below, where for Hilton Head, the ratio of tourist vehicles to households or tourist groups to households is 1:1.88, while that for Beaufort is 1:4.49, and that for Myrtle Beach is 1:1.23. And this implies that in the estimation of remaining households, much attention should be paid to tourist vehicles, specifically for study areas. And finally, future directions. Researchers could explore how boats and trailers in the traffic stream influence the estimation of remaining households. And also, researchers could account for the percentage of residents in different housing types in the assumptions for used for estimating remaining households. And such an example is mobile home residents are more likely to evacuate than those in detached single family homes. And so we feel that if these assumptions are taken care of in future works, pretty much maybe other researchers could come up with different point of views with regards to what we have discussed. So these are some of the works that we've cited for this study, and thank you.
So what I'm going to talk a little bit about while we're getting Scott's issues fixed is a study that we did, as I talked a little bit about in the introduction. What we do, Pam and Scott and I are traffic highway people. And what we rely upon a lot of times are traffic counts or traffic volume, traffic speed, to analyze to one extent or another what the traffic is doing. Particularly useful during evacuations. Well, with a lot of this COVID lockdown event that was going on, what we did is we actually, in this study that I'm about to talk to you about, we actually took those same sources of data and we turned it around to look at people not moving instead of people moving. So that was really the genesis of this idea and where we got started. So the study actually, is this not forwarding? Okay, there we go. So the study actually was undertaken by both Pamela Murray-Tuite at Clemson and Scott Parr, myself, and then John Rennie who is at Florida Atlantic University, and Carl Kim, who's a professor at the University of Hawaii. And we've all worked together for quite some time. Carl and John are both urban planners, so they brought a little bit of a different perspective to this. What we want to do, as you see on the screen, is to look at the big picture of what was going on traffic-wise and what were the trends doing. So we started to hear a lot, and it became very obvious very quickly that traffic was decreasing, traffic was dropping, and but we didn't really know how much or where. And the more we thought about it, the more in particular, we want to see how fast was it dropping and in what areas, what locations was it dropping more or less, and how was that related to what we were seeing, often in the media with COVID diagnoses and the need for social distancing and isolation, but also the need for people to, in some cases, keep working because there was a lot of people who were essential workers. There was also a lot of traffic movement that was going on with keeping deliveries, food, also moving as well. Now, this particular study focused only on, before I get to that, to finish up this slide here, what we also wanted to do is to look at how these reductions in traffic were happening with respect to government orders or declarations or restrictions, and then look at how they may have been different in urban areas versus rural areas. And then what we also look at is we also look at different types of roads in different types of areas to, we hope, suggest the type of trip making or travel that's actually taking place. So are they far distant long trips, or are they more commuting type trips? So that was the last part of what we wanted to take a look at. So the specific questions that you see listed here is what we really wanted to see. What was the overall change? Was it, did it decrease by 25% or 30% or half or 75%? We knew it wasn't complete lack of traffic, but we didn't really know exactly what it was. And then what we wanted to also look at is to start looking not just in terms of the total amount of traffic that was moving, but also looking at it in terms of spatial and temporal differences. So where and when were certain traffic decreases occurring, and were they equal, were they not equal, were they more or less at different times and in different places? So what we looked at, and you'll see that this particular study that I'm talking about is sort of limited, and we've been continuing to study this since. But in this particular study, our goal was to do something fast, to analyze these big picture issues, especially during the onset period as traffic was tending to decrease. And then since then, what we've looked at is kind of the low point, if you will, of traffic. Once we hit bottom, how long do we stay at the bottom? And then how fast did we come up? Did we come up fast or slow? Or what were the conditions? So in this case, we only looked at the state of Florida, although we're continuing to work with other colleagues across the country and even internationally to see if there's been differences in what traffic has done. And what we did is we looked, our comparison was based on kind of an average, if you will, or a prior year condition. So what we looked at were traffic on same days of the week for the same study period in 2019 versus what they actually were in 2020. There's a lot of different ways that we could have compared it, but we felt that given the fact that you have holidays and Florida is so connected to travel and to tourism travel, that was probably the best way to do it because of this amount of seasonal variation. So what we did, and it's probably a little bit easier to show you the pictures, is we used the Florida Department of Transportation permanent monitoring sites. So if you see on the slide, they have statewide coverage. There is a total, I believe, in the network of, I'm going to flip back here, 262, of which 212 were in a state of operation or sending data automatically throughout the process. What you can also see on this map are these pink areas that are designated by the Florida Department of Transportation as urbanized areas. And we can debate the definition of what's urban or not urban or suburban, but based on, we in our study used the Florida Department of Transportation definition of what was urban. Then the other designation that you see that's different here is the fact that some of these sites are on freeways, some of them in urban areas, some of them in rural areas. And other of the monitoring stations are what we call arterial roadways. So these can vary quite a bit depending on where they're at and what their purpose is. In some cases, they could be effectively two-lane rural roadways, and in other cases, they could be, 6 or 7 or even 8-lane roadways in urban areas. So what we were trying to do is take the big picture view and then look at specific areas within this data set. And what the original data set from January 1st through March 28th had 2.1 million individual hourly observations. So we had quite a really good set of data. So in terms of the findings, what is it that we found? In terms of the big picture, the statewide analysis, if you will, and I'm going to show you this graphically in a sec, but I just wanted to give you some of these key dates so that I explained a little bit in words, and then I'll show you in pictures in a second. But March 9th, a couple of months ago, were the first 2 official COVID cases. And I'll mention that one of the difficulties in doing this study, what we wanted to do is we wanted to use traffic as somewhat of a representation of people's levels of activity, especially outside of the house. And you could maybe even extend that in some ways to their level of interaction with one another. It's not a complete, perfect connection of those dots, but that's what we wanted to look at. And what we thought we'd be able to at least shed some light on is what was going on in terms of people's behavioral response, if you will, and we know how that works in evacuations, to certain government orders or closures or requests for social separation. And also how that was, if we could, related to COVID diagnoses. That can be troublesome too, because diagnoses, as a lot of people have already discovered, is that they kind of come and go based on when they get the tests in and what data is available on which days. So then we thought about using hospitalizations, and so there was a lot of different ways we could look at this. But we simplified it by just looking at the official numbers of positive COVID diagnoses. So the first 2 were on March 9th. Within 3 days, we could already see that traffic was declining. And when I say we could see it or we could observe it, what we did is we didn't go just purely on numbers. We actually used statistical testing, as academics, as researchers. It has to be statistically significant because traffic can vary quite a bit, not just from year to year, but day to day and hour to hour, even minute to minute traffic can vary. So we want to make sure that these were statistically significant. So we started seeing a decline that early, March 12th, and then by 3 days later, that's when you started seeing a lot of the park closures. And by March 15th, only 3 days later, then there was 50 confirmed cases. Traffic was down by 12%. Within a week, that's when there was an order to close bars, nightclubs, and dine-in restaurant service statewide. And by the way, I should also mention that there's variability from location to location. So we were trying to look at statewide orders. Traffic was now down by 23%, so about a quarter from where it was within about 10 to 11 days. Within only 2 days after those closures, that's when the major drop. Excuse me, it says March 28th. Excuse me. By a week later, the COVID cases were now in excess of 1,100, and traffic was down by nearly half of what it was in the prior year. So when we look at this graphically, and I'm going to kind of try to show you, I don't know if my cursor shows, in this graph, what we have is this black line represents basically all roads within the state of Florida. The yellow lines or gold lines here represent just the urban roadways. And then the blue lines down here are the rural roadways, all rural roadways as defined by the Florida Department of Transportation. And then this red dashed line right here represents the COVID cases. And then you see on the x-axis, if you will, that is the temporal axis or time. So basically this is the period from March 1st through March 28th was our study period. And the reason why we picked that is because that's when a lot of the things were happening. There was a declaration of a statewide state of emergency, the schools were closed, Disney closed, bars closed, restaurants closed, and you can see what you see on this, I'm going to try to get my hands correct, is actually as we go on, there's a bigger and bigger departure from 2019 to 2020. And what you can also see is if you compare the yellow and the blue lines here, is that we see much more pronounced differences, and I'll get into some of the numbers here, much more pronounced differences in the urban areas than what we saw in the rural areas. There was also a bit of a delay as well. One of the things that makes this difficult is that urban areas carry about 5 times as much traffic as the rural roads. So that's where we had to use some statistical analysis to make sure that even though the differences in total might have been relatively small, that it still represented statistical differences. One other thing I'll also point out on this, 2 other things actually, is that you notice, well, let's just look at the statewide numbers, these 2 black lines here, the dashed line, which represents the 2019 traffic statewide data, and then the solid line here, which I'm trying to outline here, which represents the 2020 statewide traffic volume data. As we go further and further in time, they become further and further apart, meaning that the differences were growing more and more and more by the day. What you also notice here is, unfortunately, our study period was cut off while traffic was still dropping. We're just getting that data in now, and now that Florida is in phase 2, I believe about to move to phase 3 pretty soon, we're going to be able to tell how much of that traffic has returned. So when we look at the differences between rural and urban, I just mentioned this, that urban area tends to constitute 5 times as much in terms of the total volume carried. What's interesting is that the most notable decreases in the urban areas was about a week before the rural areas. So we saw that traffic was really starting to decrease, and then it was about 5 or 6 days later that we really started to see the same decreases in traffic in the urban areas. What was also interesting is that we had a lot of weekend to weekday differences. So particularly in the urban areas. And what this was suggesting is that people were starting to stay in or travel less on the weekends, but there was still travel that was going on in greater numbers during the week as people still had to go to work. So that was kind of an interesting finding. And you see also by the end of the study that we had about a 50% decrease, 48.3 in the urban areas, while it was still significant, it was somewhat less in the rural areas. Then when we look at freeway to arterial roadways, we see that there was a much more significant drop in freeway traffic, down by more than half, where arterial traffic, and these were the types of trips where we would expect it to be less, because this was people going to the grocery store or commuting back and forth to work, where they would not be taking long, statewide trips, but that was more travel within their local area. So that was something that we would have expected. Now, what's interesting here in this point right here, I said there were similar trends between traffic decrease and confirmed cases of COVID-19. I'll show you that in a second on this graph. So again, we go back. This dashed red line represents the COVID cases. And what this is now representing, this is a little bit confusing, but I want you to make sure that you all understand it. So what we have on the y-axis with these lines here is the percentage of decrease from year prior levels. So if we had a 0% decrease, that means that 2019 and 2020 were the same. By the time we got to the end of March, we were about 50% different, or 50% lower than the 2019 levels. And what's interesting is you can see that the relative trends of the decrease pretty much mirrored, if you will, the trends in the COVID diagnoses, the positive COVID diagnoses. And you can see that was continuing to go way up. By the way, that also represents the cumulative cases that we would have. That were observed in the state of Florida. And you can see there's also a little bit of separation between the decreases in the rural roads versus the urban roads. So in terms of the broad findings, hopefully Scott has his microphone issues solved. But in terms of the broad findings of this is that one of the questions we wanted to look at, the kind of the epicenter of the outbreak, if you will, of COVID diagnoses in Florida initially was in, as we would expect, the most densely populated areas of Southeast Florida. And so what we saw was that the most significant travel reductions were also in that area. We also noticed that it was most significant after schools were closed, again, which we would have expected, because you have now people are not taking their children to work, children to school, on top of not going to work. Again, I talked about the fact that the rural decreases in traffic happen later, and this tends to suggest, as I said earlier, that long trip travel was decreasing much before the local travel was. And what was also interesting is that while the emergency declaration did have effects on decreasing the traffic, it was really once things started shutting down in terms of trip attractors, whether it was employment or restaurants or entertainment, that's when we really saw traffic start to go down. But again, it's not necessarily a straight cause and effect. There was a lot of compounding effects where people were traveling less. So how does this all relate to evacuation? And this is the big question, and this is the main point of this presentation, is that one of the issues that we've heard, and that you probably, if you work in emergency management, are well aware of, is that certainly it's the case here in Louisiana that they want to maintain social separation or social distancing within shelter locations, public shelter locations, which obviously would have to cut down on the capacity of these shelters. There's also talk about the need to screen evacuees as they're entering or setting up certain areas I don't know what you want to call it, quarantine or restrictions for people who might be displaying certain symptoms, whether it's fever or cough. But and that could greatly impact our ability to shelter people. But at the same time, what I'm seeing evidence is overwhelmingly is, before I get to that, one of the other things too is the other things that may impact the need to shelter or evacuation that I've heard discussed. We don't know this because I don't think anybody's evacuated. But people who haven't worked are going to have a greatly reduced amount of resources or income to make those trips or to do travel. But they also may have a higher need to shelter if they cannot shelter or pay for a hotel someplace, or they don't have relatives or friends who are going to be more as accommodating with all of the potential virus going around, that people may or may not be less likely to evacuate. So doing some research just today. I don't know if you've seen this, but you can Google. There's a AAA study statewide in the state of Florida, and there's a lot of very interesting findings. We'll see if they're actually true or not, if an evacuation happened. But 42% of Floridians stated that they are less likely to evacuate in 2020 than they would have been in 2019. In fact, 29% stated that they would not leave their homes under any case even if they were advised to evacuate. Again, we'll have to see if this is true, if and when there's an evacuation. So in terms of what we do, traffic movement and clearance time, if potentially less people are evacuating, that may actually increase the ability to move people in shorter periods of time. And if tourism is less, that could also get less traffic on the road, which could also potentially benefit clearance times. And I'm gonna hold it off there in terms of going into any more detail because I want to make sure Scott has time to present. But those are some of our major findings. Again, we're continuing to do the rebound, if you will, or the recovery study in Florida. We're also looking at even things like emissions and pollutants with decreased traffic. We're looking at differences nationwide in terms of adherence or less travel based on government regulations. And we're even working with people in Germany and Australia, the Netherlands, China, even Iran, if we can get data to actually do comparison contrast of other different countries. So we always like to acknowledge the people who fund our research and provide data. So Jerry Gordon from the Florida DOT, work with Scott Parr to get this data. And then we see our funders, the US DOT, the National Science Foundation, and our universities who support a lot of our research. So what I'm going to do, I was going to end it on this slide. That's our contact information. If you want to use at the top of your screens, you can do a screen capture if you ever need to get a hold of any of us. And what I'm going to try to do is turn it back over to Scott. Hopefully he.
All right. And you can see my screen.
Yes, sir. All good.
All right. Let me put some of this stuff away so I can get some work. Okay, great. Well, thank you guys. I'm sorry about the technical difficulties, as I guess is to kind of be expected with stuff like this at this point. So I'd like to talk to you about a research project we did with Brian Wolshon and Pam Murray-Tuite, and a student of mine, Lorraine Acevedo, who has now graduated and has gone off to do great and wonderful things in the real world. So just a quick overview. We're going to be talking about Hurricanes Irma and Hurricanes Michael, the evacuation thereof in the state of Florida. Broad level, we use simple traffic count data to try to quantify the elements that are going on in the storyline that is the evacuation. So we're using traffic data to show when people started moving and how they started moving, and try to get an idea of when the evacuation began and some other aspects. So first, we acknowledge my co-authors, Brian Wolshon and Pam Murray-Tuite and Lorena Acevedo. Funding was provided by the U.S. Department of Transportation at the Gulf Coast Center of Evacuation, Transportation, Resiliency, a member of the University of Texas Transportation Center Cooperative Mobility for Competitive Megaregions. Data was provided by the Florida Department of State of Transportation, and a special thank you to Joey Gordon, who helped us get the data. So the motivations for this study, really, an evacuation is successful or not successful or criticized. I mean, generally they're always criticized. But one of the motivations for the study is to say, what does it mean to be a successful evacuation? Do we have any quantitative measures that are collected and presented in an unbiased fashion? So we want to get away from the sensationalized news media and take an actual engineering perspective, a systematic quantitative approach to look at the evacuation response, when the evacuation began, how many vehicles evacuated, etc. So currently the state of the practice is to use survey data. That's been done a lot of times, and it's effective. It answers a lot of questions, and the surveying techniques are well established and refined. The problem is it takes several weeks or even months to actually get that sampling rate that is appropriate to make large scale conclusions and preparations thereafter. So the idea is that we'd like to use a measure that is an unbiased, practical, and easily repeatable, that is a little bit quicker than the current method of survey data. So in this project, we looked at a couple different research questions. All right, so when did the auto-based being vehicle driving on the road, when did that evacuation actually become apparent? And when I say apparent, I mean, when did we see a change in the traffic pattern that we would typically expect on a regular, Monday through Sunday travel pattern? Right? We'd also investigated how the evacuees loaded onto the network. So what was kind of like the exit rate of different regions? Right? When did the evacuation volume peak? What was that peak hour when most people were on the road in a region? When did the evacuation end? And what is that in reference to landfall? How many vehicles were used to evacuate? When did the reentry actually begin? And when did the reentry end? So we're going to look at these research questions and try to see if we can answer them with our traffic data. Right? So the approach, we use traffic count data. Traffic counts is just literally counting the number of cars that go into or out of a region. All the states collect this information. They're required to. And generally, the sensor arrays are throughout the region. They're in urban areas, they're in rural areas, they're on arterials, they're on freeways, and they're all over. It gives us a good idea of sampling throughout the region. Right? So the method we applied was very simple. We just drew a circle around an area and counted all of the vehicles entering and subtracted all the vehicles leaving. That's it. Very basic. Right? So here we have the only equation that I'll show is literally the summing of all of the vehicles entering and exiting a region. So step one, you draw the circle, you take all the detectors and draw a circle around the region that you're interested in. So you use the detectors as a kind of a cordon line. Then you add all of the vehicles entering and subtract all the vehicles exiting for every hour. We have hourly data, but you could do it for every 15 minutes if you had that kind of fidelity. And then we just plot the hourly cumulative change in net traffic. So hourly, this is what the summation of traffic was doing and how all of those add up together. So a little reminder, if you live on Mars and have never been and haven't been around for the last couple of years, Hurricane Irma was a very powerful storm that threatened first the northeast coast of Florida, and then as the storm path and predictions changed, shifted and pretty much encompassed just about the entire state of Florida, was under watch. So it was a massive evacuation order. I think every county or nearly every county in the state of Florida was under mandatory or a voluntary evacuation order in some region at some point during this storm event. So a lot of uncertainty around this storm. Ultimately, the storm made landfall on Cujo Key, and then again in the Naples region on Marco Island. But very big storm, very uncertain path, and we can see that in the traffic. The traffic data actually responds to different regions, and that helps tell some of the story. It helps tell some of the story of the state of Florida during this time. Hurricane Michael, on the other hand, had a very, I don't want to say confident path, but the 5-day projection was very close to the actual landfall location and timing. However, the intensity kept on revising as, every couple of hours that it was projected that the storm was going to increase. Until ultimately, I believe it was a Category 5, or it was revised up to a Category 5 at landfall. But you can see here on the image, 5 days out, they're expecting a Category 1 or 2 storm that ultimately turned into a Category 4 or 5. So here's our sensor array. The black dots represent all the sensor locations. The different regions are the regions that we're interested in. So we see Southeast Florida consisting of Broward, Palm Beach, and Miami-Dade County. We see what we call the Naples region, which is actually Collier County, and the name of the one just north of that escapes me, sorry. But the Collier County and the neighboring county. And then we see 3 counties in the Panhandle that we also looked at. So here we see the Naples region. All right, this is a nice clean figure that we're going to walk through. So here you see the blue line. The blue dotted line represents the typical average everyday traffic. And in the morning, we see a peak of traffic. That means there are more vehicles entering than exiting the region. And then in the evening, we see a decrease in traffic, more vehicles exiting than entering. That would suggest that this is a commuter area and more people are coming into the area to go to work and then exiting. So the idea is that the carryover from day to day should approximately be 0, in the sense that for every vehicle that, for the most part, over a long enough period, every vehicle that enters the region is going to exit the region. If that were not true, we would see an unrealistic buildup of vehicles into the area or an unrealistic exiting of vehicles out of the area. So the unrealistic exiting is kind of what we're trying to capture here with the evacuation. So the blue line is an everyday. Right? The orange line represents the evacuation time period. So it starts, I think, September 4th, and moves on throughout until here. This figure ends at September 17th or 18th. The other figures, depending on when traffic returned back to normal, end later. But here we see, here we're quantifying when the evacuation begins. This is the auto-based evacuations. When did the auto-based evacuation begin? Here we've quantified it as the point in time which traffic deviated from the anticipated pattern. That is to say, when the net exodus of the region was not in line with what we would expect on a typical day. So the idea is that, look, we have a net exit of people, and this net exodus does not return until after landfall. So the idea is that the cumulative traffic count is negative and remains negative until after landfall. And we said, okay, here's the first time it went negative and remained negative. And we said, okay, that's likely where our evacuation begins. Now, again, that is, of course, conflated with the ebbs and flow of traffic. But in general, we can say that, look, during this period, this AM peak period, that's when we start to see the influence of what the storm and the story that is going into what is ultimately ends up being Hurricane Irma. Right? Here next, the next major point we see is on September 8th at noon is when the mandatory evacuation orders go into effect. So again, there's the evacuation from a traffic perspective actually began 3 days earlier, not 3 days earlier, but it was 20-something hours or whatever. But we actually see that the evacuation begins, well, not the evacuation per se, but the impact on traffic begins days before the actual mandatory orders in Naples. So again, the storyline of Naples was that it wasn't really in the initial storm path. So its mandatory evacuation orders were given later after it was apparent that Hurricane Irma was shifting from the East Coast to the West Coast. So that kind of affected the mandatory order. Also important to note here, our method of just counting cars in and out of the region doesn't really account for tourists. So if there's a hurricane coming, it's likely that the tourists in the region are leaving earlier, they're changing their travel plans. Look, there's going to be a storm here, we were going to come, we were going to stay longer, but now we got to go. Things like that. We don't distinguish between tourist cars and regular cars. All cars are just cars in our approach taken here. So the next period of interest, we have the evacuation peak. So this is the hour that the evacuation vehicles peaked. So if you were evacuating, you wouldn't necessarily want to be on the road at that time. Here we see that evacuation peak happened roughly 27 hours before landfall. Typically, we'd like to see 2 to 3 to 4 days before landfall. If I put on my emergency management hat, we don't like to see vehicles on the road traffic peaking at within 24, 25, or 26 hours before landfall. We'd like to get the majority of people who are going to evacuate out of the way before that. And that's typically what we saw with the other regions that we're going to see later. It's just that Naples was kind of unique in that the storm track changed, the orders changed, and people responded later than they did in, say, Southeast Florida or the Keys. Okay. Then we have landfall on Marco Island. The evacuation ends in the sense that the last vehicle that was measured to leave left. That happened about 12 or 13 hours before landfall. And then almost immediately after landfall, within 2 hours of landfall on Marco Island, the reentry begins. That is, people actually start flowing into the region within 2 hours. So, Irma was a pretty decent sized storm. And if we think about it, that's probably as soon as the tropical force winds are kind of leaving the region. People are already in their car on the road, headed back to their homes to check out what's going on. Here we see that the reentry peaked the following day. Early afternoon of the following day is when the most people are on the road coming back into the region. And then ultimately we see that the net flow of vehicles out of the region is actually made up for by the net flow of vehicles in. The reentry equals the evacuation volume a week after landfall. So that's kind of the story that's unfolding here when we look at the different regions. The next region we're going to look at is the Florida Keys. Now here we see the Florida Keys is a much longer drawn out recovery period, right? Well, the Florida Keys was closed for like 3 weeks to non-tour or to non-residents south of the Middle Keys. So like Key West and the Lower Keys, those were closed for like 3 weeks. And that's kind of what we're seeing. That's the reason why we're seeing this delayed return back to normal traffic period. It's also evident that tourism is going to be impacted, and Cujo Key was hit by a Category 4 storm. Irma was a Category 4 when it made landfall there. So there's also some damage that's going into preventing this recovery. But here the evacuation begins much earlier. Here we see the evacuation begin on September 5th. Now, it's important to remember here that September 5th is a Tuesday, and it's the Tuesday after Labor Day. So the Keys, Naples, Southeast Florida, these are all regions that would generally see an inflow of vehicles for the holiday weekend on Saturday, Sunday, that holiday Monday, and Tuesday. Again, we're not looking at tourists and visitors versus residents. The method that we're proposing can't do that. But what it does do is just give us an idea of the overall traffic. So again, there's are those people that are evacuating, or those tourists that are anticipating an evacuation, or those people with their boats just returning home after a nice holiday weekend? Regardless, the change in traffic is a net exodus beginning at this point that remains until landfall. The mandatory evacuation orders come a couple hours after that. The peak evacuation demand comes a day after the evacuation orders, which is pretty good, and several days before landfall. The evacuation ends the night before landfall. That is the last vehicle that it was going to exited the night before landfall. Landfall was on at 9 a.m. on Cudjoe Key, several hours after the last vehicle exited, and then re-entry began within 2 hours of the evacuation, within 2 hours of the landfall. That was probably the most interesting or maybe surprising feature that we found of the data, was that regardless of where we looked, we see re-entry beginning almost immediately, just almost immediately. It was really interesting. All right. So again, the Keys were hammered pretty hard by this storm. Parts of the Keys were closed to non-residents, etc. The actual peak demand, the peak reentry demand, didn't happen until 8 days after the storm. Now you can see, if you go back a day, you can say, okay, well maybe September 17th we see a peak evacuation or a peak reentry period. Yeah, the 8th a little longer. So pretty much the 7th and the 8th was when most people were coming back to the Keys. And then again, we had to go all the way out until October 1st, 20 plus days after the storm, or 3 weeks after the storm, to see that, okay, the amount of vehicles that left have actually, the net exodus has been replaced by a net entrance. So we could say, all right, effectively the reentry has concluded here, with a couple stragglers here and there. But net, we're back to a traffic state that resembles something like normal. Here's Southeast Florida. Southeast Florida, again, another interesting finding. Here we have the most vehicles exiting. If you look at the secondary y-axis, we have, I think it was 275,000 vehicles we counted exiting. But here we see that when the storm was on the East Coast and projected to hit the East Coast, we have, an evacuation of the region. As the storm shifted closer to the West Coast, we actually have more people coming into the area after that period than exiting. So so there's two things that could be going on. One, we could have people evacuating before the storm when it was projected on the East Coast, and then coming back home to shelter at home because they were going to shelter in Tampa or Naples, etc., and then realize that was a bad idea. Or we have people leaving, sheltering in other regions, and then other people who were maybe in Naples or on the West Coast coming to Southeast Florida and using it as an evacuation destination. So the first mandatory evacuation order was given September 6th. The evacuation became discernible a couple hours after that. The evacuation peaked the following day after the evacuation orders, which makes sense, and 3 days before landfall. The evacuation ended when the net exodus, when there was more people entering the time period when more people entered than exited. We said, okay, the evacuation's over for all intents and purposes. At that point, however, there are still more people leaving, but they're outnumbered by people entering as an evacuation destination. Here we see, we pointed out the landfall in Cudjoe Key. Reentry peaks the next day in the late afternoon, and then continues until September 18th. All right. Here we're looking. Here now we're going to move over to Hurricane Michael. So Hurricane Michael, we only looked at the Panhandle, the region around which the storm made landfall. We see that the evacuation begins on October 7th, 2018, in the morning period. That continues until the mandatory evacuation order is given the following day. Then we see the evacuation peak the day. So the evacuation order is given on the 8th in the morning, and then 8th at 7 p.m. Is when the evacuation traffic peaks. Now again, if we take a look at the y-axis, we can see that the volume of vehicles is significantly orders of magnitude lower for the Panhandle region. Well, it's because of population demographics and traffic patterns of that region of Florida are significantly less than Naples, Miami, and the Keys. So you have to keep that in mind as we're looking at these. So Hurricane Michael came in and Hurricane Michael made landfall on the 10th, 2 days after traffic peaked. And here we see the yellow lines. Now, the yellow lines represent the period when when half of the detectors went dead. So we're not as confident in these numbers as we are the numbers prior to the majority. The orange line is when all the detectors are working, and the yellow line is when half of the detectors are not working. So we can't really had a hard time quantifying the impacts of the reentry and things like that, but we can see when the evacuation begins and when the evacuation peaks, we weren't able to capture reentry. So from this information, we were able to look at maybe not the traffic loading per se, but when people exited, so the cumulative evacuation. So if we say, look, here's the total number of vehicles that evacuated, we're going to represent that as 100%. Okay, how long did it take for 90% to evacuate or 50% to evacuate? So in the future, we can say that, look, we can't plan that 100% are going to evacuate all the time. We can't make our protective action decisions based off of time needed to evacuate 100% of the people, because everyone has different things going on. Some people got to go to pick up their grandmother from maybe an assisted living facility, bring her home, make sure you go to the pharmacy and pick up your prescriptions, pick up grandma's prescriptions, all of these things. So it's maybe not the best to plan for 100%, but maybe you want to get to 90%. And we can see here that there are significant discrepancies to get that last 10% out. That's the evacuation tail. Those are people that decide to evacuate later or have other things that are going on that prevent them from evacuating other than just traffic, other than the typical, what most of us would experience. So here we were able to see when 90% evacuated or 50% evacuated, but we're also able to see when 90% were able to return, or when 90% or when 50% were able to return. And from a perspective like that, we can say, all right, well, how long were people displaced for? What is the displacement time for half the population? So if you were to go over and calculate the difference between, say, you take that 50% line, go across, calculate the time between when the evacuation was at 50% and the reentry was at 50%, and that'll give you an idea of, in general, how long people were typically displaced for. So in summary, these are all the evacuation times and total vehicles evacuated, and so this is a summary table of the results that we discussed earlier. So again, the approach here is, it's a little, I wouldn't necessarily say it's rough and dirty, it's quick and dirty, but it is quick and it's not that dirty, but there are some limitations and basic assumptions that have to be discussed when talking about the implications of any of the results. Is that, the assumption is that on a typical day, roughly the same number of people enter as exited. And we can show that in the data that on a typical day, yeah, all right, the people who enter exit. That just happens. So that's an assumption. It's not necessarily true in all cases for everybody, because you have tourists that enter, stay for a couple of days, and then leave. So you have little bumps and little perturbations in the data. But if you're looking broad scale, you're not looking at hundreds of vehicles. You're looking at the larger scale of thousands of vehicles or tens of thousands of vehicles. Well, then, yeah, this assumption really works. All right. Again, we didn't distinguish by trip purpose. We only looked at any vehicle, so it was a little hard to distinguish between who was evacuating and who was just leaving, because their rental car was up and it was time to fly home. Again, the method doesn't include visitors and residents. Also, if your region is used as an evacuation destination as well, then you're actually counted as +1 and may negate someone who was actually leaving later. And also, if you evacuated and stayed within the region, so you evacuated maybe from the coastal area and went to the mainland, but didn't evacuate the larger area, you weren't counted. So in conclusion, the storm begins to impact traffic well before the evacuation orders are given. Again, we can't know this for certain, but it's likely that tourists and visitors are the first to leave, and therefore that's kind of what's impacting traffic. The evacuation then typically peaked 2 to 3 days before landfall. That's a good thing, you know, and except for the Naples region, which was much closer, but that's because the storm track changed. So as storm predictions get, oh, I messed that up. As storm predictions get better, we're going to you're going to see that better predicted storms are going to give better evacuation results. Reentry generally began the morning of the early afternoon of the next day, reentry began roughly 2 hours after landfall, but peaked early afternoon of the following day. Except for Florida Keys, which really wasn't possible to do that because of the storm damage and the precautions taken to limit reentries. And traffic then returned to pre-conditions until typically a week, but again in the Keys it was longer. So thank you very much. I guess we'll open it up for questions.
Yes, Scott. What I'm going to do is I'm bringing everybody back here. We didn't have anybody type any questions in, although we had a person say that Lee County is the next county north of Collier County.
Yeah,
and
that's
they're
it.
going to, and I responded back and said that they're going to revoke your Florida residency card, Scott, because you didn't know that. Obviously, you didn't listen.
Listen, I grew up in Southeast Florida, okay? They're outside of Broward, Palm Beach, Miami-Dade, and maybe the Keys. There's not a whole lot else out there. Come on.
Nothing existed, huh?
Yeah, that's Florida. Everything else is someplace else.
Yes.
Lower Alabama. Now I'm gonna get killed.
Be careful, there's a lot of Alabama folks that are out here. So I don't see if anybody has any questions. Does anybody else have anything that they wanted to follow up on? Anybody on the panel? I don't know I hope that all of our presentations made sense. We apologize for a bit of the technical difficulties. Especially me and my presentation, it kind of caught me off guard. I was a little flustered during the discussions that I was talking about. But I guess, David, if we don't have any questions, if you want to call it, we're fine with that, but as I said earlier, our email addresses and our contact information, Scott's is still up. If you do have questions about that, about anything that we talked about, we'd be happy to try to answer them for you. So I think that is it. David?
Yeah, that's all. We're all good. We're all good to go.
Okay.
Great presentation, guys.
Thank you very much. Everybody stay safe out there. Thank you.
All right, thank you, guys. Bye-bye.
Bye, guys. Thank you.